We got Bobby's Hobby Shop here, selling model rockets. The rocket manufacturer claims that the rockets can soar as high as 550 feet in the air into a parabolic path according to this equation. Is the manufacturer's claim accurate? Now these questions start to show up like this when they don't necessarily say make sure you complete the square method or make sure you do this or that. We need to think about, okay, if we can find the highest point or the maximum point, we need to kind of get to that point where we understand that that is a maximum height type problem, where we're going to need to use the equation involving h and k, y equals a times x minus h squared plus k, to get the solution, because the vertex is located at hk. Okay, so to do that, we are going to we're going to take the given equation. We got to do some work our magic on it here. Okay, so the equation is y equals negative 2 x squared, upside down parabola, and we can picture that it's a rocket that's shooting, plus 60x minus 352. All right, well, I've instructed my kids to move the 352 over. We're going to add it to both sides to get rid of it for now, so I got a y plus 352 over here. And it's equal to, and then with what I have left, I'm going to take out that negative 2. I could take out a 2x from what I see there, but I don't want to. I want to keep that x squared. So taking out the 2, hello, I just did never mind. So taking out the 2, I'm left with an x squared, but if it's a negative, then that plus 60 is going to become a minus 30. And the x is still there because I didn't take the x out of both, even though I could have. If I did, I wouldn't be completing the square, so that would be a problem. Okay, so now I need to complete the square by adding whatever it is that I need to add, and that we find is found by doing the b over 2 squared thing, where b is the number here, not this. I know we sometimes will want to try and jump straight to the b over 2 squared thing. Well, we don't want to do that here. The b over 2 is the b inside the parentheses now that we have the x squared. It has to be an x squared to identify our b, a 1x squared. So we've taken out the 2 and we're good to go. Half of 30, negative 30, is equal to 15, and 15 squared is equal to 225. So I'm going to add 225, and I'm going to add 225 to both sides. However, that 225 is actually times a negative 2. If I add a 225 times negative 2 inside the parentheses, I have to add a 225 times negative 2 on the other side as well. Okay, now that gives me a 550. And so if I've got 550 that I'm taking away from 352, that leaves me with 148 in the negative side of things. So y minus 148 is equal to, again, that's a 225 times negative 2. That's a negative 550. And so I'm glad I checked. And just for fun, you know, I'm doing this in my head. We have these wonderful things called calculators. 225 times negative 2. There's your negative 450. I was saying all kinds of different things. If I subtract or add that to 352, we get 98. Okay? So I don't know where I was going, but I meant to say minus 98. Okay? And it is a negative 98 because the larger number, the 450, is negative. So back over here, I've got a negative 2 and I've got an x and then minus 15 squared. That is, if I factor this thing, I get x minus 15 and x minus 15. And the short way of getting that number in the perfect square is just whatever the result of the b over 2 is before you square it. Okay, so we move the 98 over. I add 98 to both sides. And I end up with a y equals negative 2 times x minus 15 quantity squared plus 98. Well, back to the question. The question says it can soar as high as 150 and according to this path. Well, the vertex is at 15, 98. So it appears as though, with 98 being the highest it goes, appears as though it's not going to go as high as they claim. Okay, we'll leave it at that for now. As prove your answer with a graph, an equation, and/or a written description of your reasoning. If this represents the maximum value, then the maximum value should only go to 98, and 150 is a little high. But while we're at it, we have number 4. It's working with the same equation. Okay, the same scenario. However, the manufacturer is also claiming that it'll land over 10 feet away from the point at which it was launched. Same parabolic path, height of 98. But the cool thing is here we can utilize this, and if we can kind of get a visual on the image, you go over 15 and up 98. If that's 15 and that's 98, there's an upside down parabola kind of going on here. Now, what we don't already know is we don't know where this thing lands or how far each side is. Well, that's because we haven't been able to look at the roots yet. Now, roots are going to be found by either doing the quadratic formula or various other things. And so if we take the original equation and we say let's factor this thing, the first thing you might notice is that they're all even numbers. So one thing we could do is we can take out that -2. If I take out -2, I'm left with x squared minus 30x, but then it'll be a plus 176. That's if I divide each of those original numbers by -2. So this right here is now potentially factorable, and that should give us our two solutions. We know they're going to be symmetrically on both sides of the 15. We also know, according to this, that the two numbers will add up together to get -30, but multiply together to get 176. Now, off the top of my head, I'm not exactly sure what those numbers are, and we can try a couple different things. 176, and I guess instead of me stammering through this, the other alternative is to use the quadratic formula, where x is equal to negative b, which is a -30, plus or minus the square root of -30 squared minus 4 times 1 times 176. By the way, if you didn't factor out the 2, you'd still get the right answer. But because the 2's factor out, these are the A, B, and C come from inside. So that's all over 2 times 1. Okay, if we use this, that -30 is going to become just a 30. Plus or minus. Well, 30 squared is 900. And 4 times 176 is equal to 704. So I've got 900 minus 704. Well, that's in our wheelhouse there, I think. Plus or minus 900 minus 704 is 196, which we know is a perfect square. 196, the square root of 196 is equal to 14. So I can take the square root of that, and I get 30 plus or minus 14 all over 2. That's two solutions that I can actually work out here. 30 plus 14 is 44, divided by 2 is 22, and 30 minus 14 is 16, divided by 2 is 8. So I got one at 8, that's over here, and that's 7 units from this side, but I've got the other one is over here at 22, also 8 or 7 that direction. So there we have it. The question then is, it can land over 10 feet from where it was launched. If it was launched at 8 and it landed at 22, the difference between those is actually a 14. Okay, so that appears as though, even though they weren't accurate on their height, they are accurate on the fact that it spanned 10 feet or more.